This is MongoDB. Brief introduction. My nickname is Waldo, but if you need to find me professionally, I'm Harold Grunenwald. I self-identify as a geek. I get off on solving problems, and I found that the career of systems engineering and teaching myself to code have given me lots of areas to find cool problems to solve. On Twitter, I'm gwaldo, and also on GitHub. If you want to follow along, I've done my best to publish the conference schedule as best I could put it together in JSON format, and it's up there under a repo called NELF 2013, all uppercase, no spaces. Quick caveats: I have no affiliation with Tengen. I know some of the people there; they're awesome, but I'm not being paid for them, though they did offer me a T-shirt. On language, I'm going to try to keep it clean, but I am an ex-Marine of 8 years, and so it's kind of how I talk. So I will try to be nice. I apologize in advance. Well, what is MongoDB? It comes from the name of humongous, for being able to scale to handle huge data sets. Basically, the founders of MongoDB were trying to make Google App Engine, and then Google App Engine happened. Google released it, and they went, well, what now? So they cried in their beers for a few days, and looked at the parts that they had put together to see if there was anything salvageable. And they said, well, a data model is kind of cool. We can do a database of arbitrary JSON. Let's polish that up and ship it. So, as I said, it's the data resembles JSON. It's actually BSON, binary formatted. If you want more information, there's a website, bsonspec.org, that describes exactly how it is. But you can think about it as JSON. It has a lot of common features that you expect out of any real database. It does indexing, querying. It's no use putting data in if you can't get it out. This is what a very simple query looks like. You can do replication and sharding, and both of those are stupid simple to set up. Really easy to get going once you start needing to put it into production. As part of write protection, going from memory to disk, you can enable journaling. It's actually enabled by default. It didn't used to be as of version 2.0. You can set write concern for when you have your replica sets. You want to ensure that if your write to the database doesn't return OK until it's reached n number of your secondaries. You can do stored procedures and just plain old JavaScript. And calling them is about as simple as you'd expect. It seriously has a lot of features. There are one of the criticisms that, skipping ahead, it doesn't do everything that a database like MS SQL or MySQL or Oracle, it doesn't have all the features that they have because it hasn't been around that long. But seriously, there are a lot of features, and there's a lot of awesome built into a pretty small footprint, time and size-wise. So MongoDB is a document database, and we're not talking about PDFs or HTML or Word docs. You're inputting arbitrary JSON objects, and you can think of those, if you're not familiar with them, you can think of them as Ruby and Perl arrays. I could be reading this. Ruby and Perl hashes, Python dictionaries, and PHP arrays. It's open source. They do all their coding in public. And this goes for all their projects. The server, the client, any number of tools. They've published a lot of just add-on tools, like some monitoring apps. Their documentation is a repo. It's all under AGPL, but if you want a commercial license, that can be provided to you. And they love contributions. It's very performant. It has a relatively low memory footprint, just to be running until. Unlike They decided to not solve the problem of how do we handle memory management. They let the kernel do that. I didn't mention platforms. It runs on the Unix families, including, of course, Linux and Mac. It can run on Windows, but why would you? And it has, of course, clients for all the. It is recommended that you run on 64-bit and not 32 because you hit caps at relatively small sizes. I think it stops working. It doesn't work after 2 gigs of a data set. But other than that, when you're on your 64-bit server, it is very, very scalable. It's full-featured. Any kind of a query that you would expect to be able to make, you can make. It does complex. You can use complex indexes. You can query for multiple properties. You can choose to return or ignore arbitrary numbers of the fields that you have. Geospatial indexing, that came out about a year or 2 ago, and that's pretty cool. If any of you use Foursquare, they're leveraging that heavily. But what do I mean when I say NoSQL? Perhaps non-relational isn't the best way, because your data can be relational, but the server doesn't enforce that. The better way to say is NoSQL, because it doesn't use SQL syntax. You're querying for objects with properties. Yep, I mentioned platforms. Yeah, you can. They maintain packages for all the common package managers. Though honestly, if you're on Debian, Ubuntu, or the Red Hat families, you're best to go on their website, and they maintain their own repositories that are up to date. Whereas if any of you have used a package manager before, it's typically lagging behind pretty significantly. They maintain a lot of popular languages, but there are seriously too many for me to mention that are community supported. There are language drivers for just about everything out there. And if you find one that isn't, please contribute. So here's a quick translation table between terms from the SQL world to MongoDB. A database is still a database. A table is called a collection, but you can run show tables and it works. Instead of having a row, you have a document, and it's again that JSON object. You have fields. Joins is tricky because joins doesn't. That is one of the things that you cannot do in Mongo. You just cannot do a join. You can do it in your application layer, or you can set up your data model so that you do. Actually, I'm skipping ahead, but you can set up your data model so either by ref or by embedding some of that data in your original field. But here are some basic SQL queries compared against their equivalent MongoDB queries. And honestly, I like reading the Mongo better. That's just me. These are some things that it's good at. And really anywhere where you may have a flexible schema, you may not know exactly what your app is going to look like, or you have a web app where you have live customers and you can't afford it. You need to run some updates to your application. You need to update your schema, but you can't take an outage. This is a very good alternative because you don't need to take an outage. There's no traditional schema that is enforced by the database. You just add a new object, or add an object with a new property, or you append a property to an existing document. Things that it's not good for. If you're doing a banking website, if you're doing banking, your Mongo is not a good choice. It is not ACID compliant. You can't roll things back. It's if you need joins, it's just not going to work. If for whatever reason that is a core feature that you need for your application, it's not a good choice. And data warehousing just honestly doesn't make sense because you're archiving old data. You know the fields that you have. So just go put that in something SQL. Another reason why that doesn't make sense is, you'd be better off with size-wise in warehousing. You'd be better off exporting CSVs and gzipping them up, because so you mentioned this, what each field is once, and then each row is its own document, and it falls into a nice grid. This, you're mentioning the property and value every time, so that wastes space. On the other hand, to further along that spectrum, this is much better than XML, especially transmitting over the wire. Even if it was JSON and not BSON, because you don't have open and close tags, it's just a property and a value. And there's a much higher data to or your values are a higher proportion than your keys. So I mentioned this earlier. Yeah, it does not do joins. You design your data model with by ref or by copying data periodically, or you can do it in application logic, which is personally what I prefer. Actually, this is wrong. So a common complaint, and this is a legitimate one, is that MongoDB the MongoD process had a global write lock. So anytime you had to write an object, the process took a lock on the disk and wouldn't release it until that's done. So if this has been fixed, it's now per database, and in the next 1 or 2 versions, we're on Mongo 2.2 right now. 2.4 is due to come out in the next few months, and within a year, 2.6 will be. In one of those, we'll have table level locking, and soon, and the next thing after that, they will have document level locking. Those are in the works. So the way to because Mongo because it still has a write lock. The best way to get around that is, and because it uses mmap files, it uses the kernel to determine what is in active memory. The best thing to do when you need to write a document is to query it first, read it in, get it in your active working set, and then you update it, because then it's not putting a global, or when it's cold, you're reading a document cold. It puts a lock on, it reads the file from disk into memory, makes your change, and then writes it out. And then it releases. Whereas having it in memory, it saves that pulling it from disk first. It's a much shorter time with a global lock, with a write lock.
I think recently they actually added support where they check if the page is in memory while they're holding the write lock, and so they don't fault while they're holding the write lock.
Oh, okay.
And that's lots of things.
Nice. Thank you. Did everyone hear that?
So in one of the most recent releases, they added code to check whether a page is in memory before page faulting on it, so they don't page fault while holding the write lock of the collection. And the lock is also for collection. You mentioned that, right?
It's per database now. In the next 1 or 2 releases, it will be. They're expecting to have table collection level locking down to collection. So queries are case sensitive. One of these does not equal the other. And to that note, you need to enforce within your team, your developers who are writing data out, that they are consistent with their with the objects that they're writing. Make sure that you just provide some kind of guideline as to how they should be writing their apps. So further on the caveats, it can hold arbitrary numbers, so don't treat them as strings if they're not strings. Document sizes are capped at 16 meg, which is actually a lot of text. But that's not a complete stoppage. You just then need to implement gridfs, which is kind of a file system within it, and then it chunks out the objects onto disk, but it knows where they are. If you, unless you're concerned about about the return times from your application to come back, grab the last error. Make sure that your thing wrote, and handle that exception. If it doesn't write, find out why and try to write it again. Using limits when using find. Now, this actually isn't as important as I think it may have once been. This, I think, is an old slide, so I apologize. By default, well, when you're using the console, by default, it sets a cursor of 10 objects back, roughly. So, and when using the JavaScript console, you type your query, and it'll give you some of them back. It acknowledges the existence of more, and if you run append a count to how many results were there, it'll tell you how many there were, but you just won't see them all at once. There are a lot of cool tools that they have included. For one thing, one of my gripes about Mongo is that, like, to rename a document or to rename a database, you need to stop the MongoDB process and rename files on disk, which is kind of ghetto. But they do have a lot of cool tools. That's one of those, perhaps not low-hanging fruit, but less important things because there is an easy workaround. But MongoStat, it's kind of like top for Mongo. db.server status is pretty awesome too. It tells you what your replica sets are looking like, and just how healthy is it. You can do on any given query, you can run an explain to see what it's actually going to try to do. And on your queries, if you have indexes that you're not sure or you just want to enforce that it leverages the index in what order, you can provide hints as well. Obviously, in your monitoring and metrics, which of course everybody's doing, you want to look out for page faults, for index misses, and queue length. There is a limit on the number of indexes you can do. By every document you add gets an ID, underscore ID identifier, and that's automatically indexed. And I think you could do 2 more indexes. So the goal there, of course, is to make sure you're indexing on things that actually matter, that you will query for. And of course, with any querying, you want to use those indexes to narrow down your working set, your possible set as much as possible. So, does anybody have questions so far?
So one comment on get last error. On get last error,
Yes.
I think they actually, with write concerns, you don't need to call get last error if you specify a write concern that is, requires it to have been acknowledged by the server or one of the other settings.
But I think it still does.
Oh, you do?
Well, I don't think you need it, but it's it's less important then, but it still returns a return code,
Okay.
right?
Oh, so I'm actually don't use Mongo, but
Oh, okay.
I read about it a lot.
Okay.
Because I take an interest in database APIs. And
Everybody has a hobby.
yeah, so I think write concerns were meant to replace that because the problem with get last error is it does the extra round trip.
Right. That is true.
And so I think they were looking to fix that.
Okay.
Yeah.
So at this point, I have some data set up, and I could, if we want, I can do a live demo. I'm going to cheat and copy and paste commands that I've already set up, but because this is not a test of my typing, but I'd rather show you guys how. Yeah.
Have you built any Mongo apps?
I have, but more of my time has been spent as a systems engineer backing them.
Or work with people who've built
Yep.
Mongo? Something I'm curious about.
Yes.
So if I have 2 clients connected to a Mongo server,
Yep.
and let's say I'm doing an Amazon.com type app. So one client, I want to get a list of products that meet a certain criteria.
Mm-hmm.
And it's a lot of items, so I'm going to allow for pagination.
Okay.
And so my first client goes out to retrieve rows. It gets the first batch of 20. And the second client is attached and actually does an insert, update, or delete on the collection. When that first client goes back again and again and again, it might end up picking up work, items, for example, that weren't really there when I started
if they're in memory, they'll be returned, but if they're removed from disk or removed from active memory or the disk, then I imagine, like, that's a typical race condition problem,
It's
but
not behaving like what I'll call a normal database.
Excuse me.
It's not giving me like a read consistent view of every row, every document that met my find operation, because there really is, transaction-wise, there's no way to have a snapshot for the reader.
right.
So what I'm curious about is how do people program around that kind of limitation?
Well, I don't have an answer for you, but I don't know. I honestly don't know how it handles two operations that would directly impact one another. And for some reason, I want to say that they don't handle them concurrently. They wait for one to finish before the other one takes effect. But I don't know, you would have to decide within your development team how you would handle, like, a search has returned an object and then it got deleted in the next operation. This object, this item in my store is no longer available for sale. I'm sorry, customer. I honestly think you would have to prototype that out and see what the actual behavior is, because I can't give you an answer on that.
Okay.
So would we like to see a live demo?
Yay, demo.
Okay.
We have about half an hour.
Oh, great.
Did you also include MapReduce also?
I'm not sure if I heard you. Does it have MapReduce?
Can you show MapReduce in demo?
I cannot, no. I haven't done much with MapReduce. They do have that, and they also have an aggregation framework that's newly added. So you don't need to do MapReduce for everything, but I don't know MapReduce well enough to demonstrate that. But they have excellent docs. Massive cop-out? All right. So again, like I said, I am not testing my typing today. So I have a preset Mongo process. I'm establishing a database path where I want the data files to be stored there, and I want my logs to write there. It makes perfect sense to have if possible, have your logs and journal, if you're using it, live on a separate spindle set than your database. And I am specifying a TCP port that is not open to everyone, but the default is 27017. And I already have a file there, but it's listening now. I'm going to start up my Mongo client. So now I'm going to run show DBs, and you can see it's an empty database. If you went to my GitHub project, this is a schedule. This instance, it is highly normalized data. This could very easily go into a relational SQL database. And some of these talks don't have titles, and you could very easily in your relational model, your relational schema, you can just make that field optional. Oops. So let me just start the process. So I'm going to run a Mongo import that can take many different types of files. Off the top of my head, I think you can take a BSON dump, you can take JSON, you can take CSVs. I don't remember what other options are there, but man Mongo import works very well. I'm going to Mongo handles database and collection references as implicit creates if they don't exist. So I don't need to do an implicit create me a database. I'm going to make with the -d. I'm going to import it into a database called NELF 2013 into a collection called schedule, specifying a type and of course the file's path. And it is just that easy. Okay. So now go back to my Mongo client. And show DBs, we now have a NELF 2013 with a very small database. The text is not actually 200 meg, it's just padded out the files on disk to be that size, and it overwrites the files that have already been allocated. So now I'm going to use NELF 2013, show collections, and again we get a set of indexes and this also works as show tables. I should be copying and pasting, but to show everything we do db.yourtablename.find with parens, and it gives me, the top n, I forgot how many are here, documents that are returned, and it provides me a cursor so I can hit IT and do more. Again, this is the Mongo shell. Can everyone see that? Can anyone not see that? Okay. This is the Mongo shell. It's I forgot what JavaScript engine they're using, but they're going to be using V8 pretty soon, I think in the next release. This is a fine tool for looking at your data and doing occasional work on it, but don't code to this in real life apps. Yes, ma'am.
You should ask if people know what this data set is.
I'm sorry?
You should ask if people can figure out what this data set is.
Can anybody figure out what this data set is? Thank you, Sherry.
Invite list for a party of dwarves.
What's that?
The invite list for a party of dwarves in Shire.
That is a possibility. Invite list to a party for dwarves in the Shire. This is scheduled for our conference. That's happening right now.
It's on GitHub with all your changes.
It is on GitHub with all of my right as I know them changes. It is correct, true and correct to the best of my knowledge, which will not hold up in a court of law. So if we want to see, you can, what do I want to say? Being pretty much arbitrary JavaScript commands, you can throw anything you want at it, but some of the built-ins are, we can do count. And I know there are 35 sessions that were scheduled with, titles and names and such that I was able to create. Well, I hate the way you wrote that out, so we can prettify that and make them look, like traditional prettified JSON documents. I don't have any nesting here, but you can have JavaScript arrays in there and go as far down as you want. Also, if you don't provide any argument, you leave off the parens, or when you inevitably forget it or just type fast, it will tell you what that command is actually going to do. So let's So here I'm going to create a new arbitrary object. Now I just declared a variable and said these are its properties. I can do db.users.insert. And it, again, with the implicit collection creation, it creates me a users table and inserts an object in it. What did I want to show you there? Okay. So just for gets and chickles, we create another one. Or we set it and then we create it. We find we now have two objects. I feel like this is very boring. Is there something I can be doing that's less boring? Okay. Does that mean it's fine, or no? This just does not get any better? Because, dear God, you're showing off a database and expecting people to be entertained. So I created a new user, Bob Hope, and I managed to get his email address and phone number. I don't expect that this is actually will reach you, the Mr. Bob Hope, but we can now see. Just by doing an update, I now have. Ooh, I did it wrong. Thank you.
Syntax errors. Speakers
Syntax. Oh, I know
Yeah,
why.
I know, that sounds like, Bob Hope isn't really alive anymore, so I really doubt it's gonna come back.
That's why. Because the object ID wouldn't have been correct when I created the Bob Hope object. I was hoping that I would notice in my notes that this was wrong, because there. No. Okay, I'm bad at this.
Can I ask you to explain why you use this as opposed to MySQL?
I'm sorry, I can't hear you.
Why you would use Mongo as opposed to?
Oh, thank you for saving me.
Practical situation. What you run into? Obviously, this amount of data.
Yeah, this amount of data and a very predictable schema for a conference schedule. You can very easily do this in any kind of relational model. If you're participating, especially in Agile or Scrum development methodologies where you're doing rapid development, you don't have a specified end goal and things are changing day by day or week by week. Those are good those are good examples of where you might want to use Mongo with its non-enforced schema. Another place, maybe when you need to make those kinds of changes and you need to make those changes, but you can't take an outage and you're not, perhaps you don't have the expertise to set up a highly resilient, highly redundant, like scaling horizontally relational infrastructure. MySQL makes it possible. Master slave is easy, but beyond that, it gets pretty hairy. Mongo makes it really simple to do replication, to have your replica sets, but also to have sharding, which so you scale down for replica sets for safety, and if you want for adding high-speed read capabilities, but you scale horizontally with sharding to add when you need to scale up your writing. And what it does is you provide a shard key or one or more shard keys, and your new Mongo S process manages what parts of the cluster are holding that set of memory. So you get n number of, as many shards as you have, you get n number more write paths that again lock individually and just that much more throughput. Because multi-master replication is hard.
And how, in multi-master situation, how would it resolve simultaneous messages on the same?
I'm sorry, I can't hear you.
You have simultaneous modification of the same IP. Two different masters. How does it resolve the conflict?
One happens after the other because the same set of sharding is going to have that single object. Like only one person's going to have that.
Well, when you say multi-master, sometimes the multi-master replication.
Well, you use it.
So each shard has a separate master. So it's master-slave pairs or replica sets.
Okay, so you're not a multi-master on the same.
You split out. You split out your entire working set. You don't have a master, a writable master with the entire data set and a master with it. You chunk it out into different groups.
So that if you did the single piece of data is owned by only one
Correct.
master.
Yep.
Okay.
And then within your shard masters, you have a replica set within them. So.
That's still master slave.
So you still have you still have your redundancy. You can still add your read, your other read nodes. On replica sets, by default, the secondaries, not slaves, the secondaries are not readable from, but in your application driver, like in Ruby, when you establish your DB connection, you say I want to be able to read from secondaries. The concern there, the thing to be aware about there is the same with any replication. You may hit a secondary before it's gotten the most recent update. But the laws of physics haven't fixed that. Speed of light only goes so fast. There's going to be a second lag when you call someone on a satellite phone. Are there any other questions? Yes?
Who's using this practice?
Who's using? Tengen has a whole lot of their customers. Off the top of my head, I can say parts of eBay are using this. I think some of Netflix. Craigslist is a big customer. Craigslist and Foursquare use this almost exclusively. Obviously not for their data warehousing. Craigslist has given a good talk on that. There was Tengen has a really good presentations site, tengen.com/presentations, and they have a whole bunch of slides and present talks that people have given. There was one recently called MongoDB from a DevOps perspective, and being that I care about DevOps philosophy, I went straight to it. It was a web-based fitness app. I don't know the app myself, obviously, but it. They talk very intelligently about about some of the positives, but also the pitfalls they've run into in using Mongo. Like for instance, I usually recommend people to avoid sharding unless you need to. They didn't shard and they didn't go to, or by the time they went to sharding, it was much later than they should have. Their data set had grown so large that you can go from an unsharded to a sharded environment live on the fly, but you are going to take I/O hits because it is moving objects over in real time. So you have to deal with the I/O of that happening in place. You could say take a member of your replica set, instantiate a new separate it from there, create a new sharding environment, and then cut over to that. But you have to deal with all the usual, how to handle the data that's come in the meantime. I forgot. Did I answer your question? Okay. I started rambling. Does anybody else have any question? Oh, and thank you, sir, for speaking. You gave the B-tree talk earlier?
Yeah.
Yeah, thank you for speaking intelligently about.
One interesting gotcha that I don't know if you have on your slide, but just looking at the screen right now,
Yeah.
upper left-hand corner, and something Mongo blogged about recently. We're adding compression to Mongo. A scary part of Mongo for the new user is that object, first name Bob, last name Hope, username Hope. Mongo actually stores something that looks a lot like that string. So as he's defined his schema, that document is taking up more space prescriptive you are in field names, the
Yep.
worse it is from a storage perspective. I would argue that's the beauty of databases, right? They blogged, I commented on the blog. I think it's, they don't have a choice but to suggest that because of how they store data, but there are some gotchas when you put 1 billion objects into that table, that just going down to FN instead of first name, you might reduce the size of your on this size by 50%.
Well, yeah.
Storing the field name again.
And that's exactly what I was mentioning earlier, where you have like a CSV or a traditional table format. You establish what that column is once, and everything that falls under it is that value. And JSON falls in the middle, but XML you have that tag twice for each sub object. But yeah, thank you for that point. Ma'am.
Is there a way you can, with the objects already being stored, is there a way that you could realize, oh, I should have used F name instead of first name, and actually update that?
You can-
Or
You can upsert it, but there's no shortcut to it. You could do
If like pull the dog, pop it, when it's pulled.
yeah, you're pulling and popping.
yeah,
Now, I mean, you could change that
yeah.
I believe in a relational, you would typically like create a new table with a updated schema, and you would copy the data over and drop the old one.
You can just rename a column.
Okay, thank you.
should just be able to alter the tables.
I can't hear you, sir.
In a relational system, you should be able to alter the field.
Yeah, that's what she said. I've spent more time in Mongo than I have in MySQL.
This weren't JavaScript, correct? You said you weren't-
Yes,
you
you-
were JavaScript, so you could write JavaScript sort of procedure or whatever inside Mongo
Yes.
to go through these changes so that you don't have to, it will occur at the server.
Absolutely.
So it's faster.
And there are a lot of I don't have any of them applied here, but there are some cool projects out there that you can hack your Mongo shell indefinitely. There's one, I think it's called there's a GitHub project called Mongo Hack, where he adds all kinds of syntax highlighting, a lot of helper functions and things like that. It's pretty neat. I just haven't applied it on this machine. So are there any other questions? Is there anything else anybody would like to see? Okay, thank you very much. And if you, oh, you know what? There was something I wanted to show. Oh, the object IDs are guaranteed to be globally unique amongst your data set. So whether it's your Mongo process, your replica set, or your shard, you can override this. I'm sorry. When you create a document, this value is automatically created in _ID, and it's a large string. There's a schema to it, but I don't remember what it is off the top of my head. But it's automatically indexed. And you can overwrite that when you create your documents, but you do need to be sure that the thing you're overriding it with is at least as unique.
So if you were storing a bunch of very small JSON objects in there,
Mhm.
the document would be actually take up more space than the data.
I'm sorry?
Document IDs, how many bytes?
Oh, yes. Like 12, 16. Yes, that could actually be bigger than the rest of your data. But you're going to lose unique, regardless of, after the smaller size, the less unique any of them are going to be. Like I said earlier, that's just a shell. It's a great administration tool. It's great for playing around, but don't try to build real apps in it or you'll go crazy. Again, the officially supported languages. I know I touched on a lot of things, but this is only a half-hour quick introduction. I encourage you to play with it. It's very, very readily, very play-friendly. I do want to mention the security model. Right now, it's weak. They make the recommendation and assumption that you are in a protected environment. There is local authentication per MongoDB process, I think. it creates a new user admin table, and you create user accounts. In the works is more robust authentication and permission model, mostly because their clients are demanding it. So there are things expected like LDAP authentication and rights assignment that to be coming down the road, but right now it's assumed that you're going to be in a protected environment. So the documentation, as I say in the slide, is awesome, but contributions are of course welcome. It's a GitHub project, so just fork it, make your changes, and submit a pull request. They have, like I mentioned earlier, the presentations on 10gen's website. There are people much more cogent than I. Christina Chodorow has written two of the O'Reilly books on MongoDB, and she has a blog called Snail and the Turtleneck. She's a software engineer for 10gen, and she gives excellent descriptions of how things actually work and examples of how to, things to play with or try out. Highly recommended, very, down to earth and nerd culture friendly. I think the most recent one references Dungeons and Dragons heavily. Play with it, talk about it. So again, if you want to troll me hard, I am GWoldo on Twitter and GitHub and pretty much everywhere. But thank you very much, and I hope you have a good day.